right, so on this one, we are going to solve trig functions and find all the solutions if it's asking for that. So the first one we're looking at is 4 times cosine squared theta minus 4 times cosine theta plus 1 equal to 0. So in this case, we have a square and we have a not squared. And so what we need to do is find all the solutions for this. And in this case, because this is kind of like 4x squared minus 4x plus 1, we need to factor this. So I'm going to use the AC method, where we take a times c. Remember, it's a, b, and c. So a times c is 4 times 1 is 4. Trying to get to b, which is negative 4. So if I list the factors of 1 and 4, 1 times 4 gets me 4, but I need to get to a negative. So I need to make both of these negative. Negative 1 times negative 4 is positive 4. When I add them, I get to negative 5. Negative 2 times negative 2 will get me positive 4. When I add them, I get to negative 4. So that's what I'm looking for. So this is where I rewrite my negative 4 as my negative 2 and negative 2. So 4 cosine squared theta minus 2 cosine theta minus 2 cosine theta plus 1 equals to 0. I'm going to split them in half to factor. In here, they have in common a 2 and a cosine theta. So 2 cosine theta times 2 cosine theta minus 1. Bring down my negative. Over here, all they have in common is a 1. And so then we'll have times 2 cosine theta minus 1, because 1 divided by negative 1 is negative 1 equal to 0. We know we did it right if these two match, which they do. So you get 2 cosine theta minus 1, and then it's 2 cosine theta minus 1. So the first one I pulled out what they had in common, and then the second one came from putting these two together. They happen to be the same one. So in this case, I really only have to solve one of them. If you have two different ones, you'll solve each. Be aware that sometimes we end up with a domain error because the second part might be out of the domain of our sine or cosines. So we take 2 cosine theta minus 1 equal to 0. I'm going to move my 1 over and get 2 cosine theta equal to 1. Dividing by 2, I get cosine theta equals 1/2. So where does cosine theta equal 1/2? On our unit circle. That'll be where theta is equal to pi over 3, and theta is equal to 5 pi over 3. When we're looking for all solutions in this case, we weren't given an interval, so all we're going to do is add 2k pi. Because our cosine and our sine functions have a period of 2 pi, and we put k because that way it can keep going, and we know that k is any integer. All right, the next problem we're going to look at will be very similar to this, except it'll have a little bit more. It's going to have the solutions that we're looking for. All right, so we are looking at 2 sine 3 theta plus 1 equal to 0. So I don't have to factor on this one. So I'm just going to move my 1 over. So 2 times sine of 3 theta equals to negative 1. Divide by 2. And my sine of 3 theta equals negative 1/2. So using my unit circle, I know that sine of 3 theta equals negative 1/2 is where 3 theta is equal to 7 pi over 6. And we're going to put our 2k pi here. And then we also have 3 theta, it would be equal to 11 pi over 6 plus 2k pi. Now, we actually need to know what theta is, so what we have to do is now divide by 3. Now pay attention because we are looking at an equation If we only have theta, we don't have to divide. If we have a 3 theta, we have to divide by 3. If this was 2 theta, we divide by 2. So pay attention to what you're given. Are you given a theta or are you given a 3 theta? So we're going to have to divide each term by 3 so that we actually end up with theta. Theta is now equal to 7 pi over 6 divided by 3. And again, we don't divide by fractions, we multiply by reciprocals. So we would multiply by 1/3. So we'd end up with 7 pi over 18 plus 2k pi over 3. We'll do the same thing on this side. We'll divide by 3. So we end up with theta equal to 11 pi over 18 plus 2k pi over 3. Now, in our problem for this one, we're actually given that we are looking for the solutions from 0 to 2 pi. So if we're looking in a particular interval, such as this, we have to find all the solutions that are in there. So when I'm looking at this, I'm going to have to use k's, and I'm going to have to plug in for k to find all the solutions. So I want a common denominator here. So I'm going to use my 7 pi over 18. I'm going to multiply this by 6 over 6 to get a common denominator of 18. So 6 times 2 would get me 12 k pi over 18. And over here, we'd still use the first part and change it the same way. So we'll end up with 12k pi over 18. Now, so these are the parts I'm going to use to find my k solutions, but I need to also know where I'm going to stop. So remember, we're using 0 to 2 pi, but it's written with the common denominators. It helps you to know when to stop with your k's by where you end up. All right, so the first one we're going to do, I'm going to write which one I'm working with. So I'm working with my theta. I realize you can't see part of that, so let me scoot that over. All right, so we've got theta is equal to 7 pi over 18 plus 12 k pi over 18. So I'm going to plug in k is equal to 0. And so I end up with theta equals 7 pi over 18 plus 12 times 0 pi over 18. Well, anything times 0 is going to be a 0 on top divided by anything is still 0. We end up with 7 pi over 18. All right, the next part we would have our theta is equal to 11 pi over 18 and plus our 12k pi over 18. So I'm still using k is equal to 0. So theta would be 11 pi over 18 plus 12 times 0 pi over 18, which will get us our 11 pi over 18. So these are the first two solutions that we have, but we're still well below our 36 pi over 18. So the next one we're going to do is k is equal to 1. So that means that theta is equal to 7 pi over 18 plus 12 times 1 pi over 18. Well, 12 times 1 will get us 12. 12 plus 7 gets us 19 pi over 18. And then theta equals 11 pi over 18 plus 12 times 1 pi over 18 will get us 11 plus 12 is going to get us 23 pi over 18. So these are our next two angles that fit in our solution from 0 to 2 pi. We're still far from our 36 pi over 18, so now we'll do k is equal to 2. So theta equals 7 pi over 18 plus 12 times 2 pi over 18. Well, 12 times 2 will get us 24. 24 plus 7 will get us 31 pi over 18. And then theta equals 11 pi over 18 plus 12 times 2 pi over 18. So 12 times 2 is 24, plus 11 will get us 35 pi over 18. So remember, we rewrote what 2 pi looked like here. 36 pi is right up next to 35 pi, so we will stop because k equals 3, we would go too far. So we will stop at this point because that gets to the whole part of our 2 pi. So we ended up with 6 angles that fit into our solution of our trig function in the interval of 0 to 2 pi.